So we just learned what the unit circle is, and we are going to talk about what some of these numbers on the unit circle represent. So we went through and we talked about how we could get each of these points from using 30, 60, 90, and 45, 45, 90 triangles. And so just by understanding 30, 60, 90 triangles and 45, 45, 90 triangles, we know that this angle right here is 30 degrees, this one right here is 45, this one's 60, this one's 90, and so on and so forth. But I think we haven't really talked about what a radian is and what these other numbers on the unit circle represent. So this right here is 30 degrees in radians. And so radians, I'm going to write it over here in my chicken scratch handwriting. Radians are just another measurement of angle. Okay, so we have degrees and we're really familiar with degrees, but radians we probably aren't as familiar with. And so we can get radians by using some of our geometry formulas. And I think this is really cool because I don't think I ever truly learned it this way. But then when I went to teach it my first time, I was like, oh, this all makes a lot of sense now. So this is the unit circle, right? So we know that the radius of the unit circle has to be 1, right? So the radius of the unit circle is 1. If we are interested in the perimeter of a circle, we use the formula or the circumference in the circle's case. So circumference. That's the last time I will be writing that out. And to find the circumference, right, which is just the distance around the circle, but like obviously like around the circle, not that really poorly drawn circle. We use the formula 2 pi r, where r represents the radius. So if this is the unit circle, and we've discovered that the radius is 1, then the circumference of this circle has to be 2 pi times 1, which is just 2 pi. So there are 2 pi radians around the circle. Okay. So there are 360 degrees around a circle, but there are also 2 pi radians, right? Because all the way around the circle, we just discovered is 2 pi. So when we are converting from radians or degrees to the other, we're going to do something like this. So we know that for every 360 degrees in a circle, there are 2 pi radians. And the way I'm going to specify radians, I'm going to write RAD, like rad. Okay. So if I want to see what 60 degrees is in radians, I'm going to set up my conversion like this. So 60 degrees times 2 pi over 360. And the reason why it's 2 pi over 360 is because we want this degree symbol right here to match this degree symbol right here so they cancel out, right? We want those units to cancel out. You've probably done this in chemistry, going from grams to kilograms or milligrams. You might have done it in physics from like meters to nanometers to micrometers to kilometers. So same idea when converting degrees to radians in math, okay? So I'm going to multiply it out. So 2 times 60 is 120. So I have 120 pi, and we just keep pi normal. We don't need to put it in our calculator or anything like that. So I have 120 times pi over 360. Well, how many times does 120 go into 360? It goes in 3 times, right? So I'm left with a 3 on the bottom. So my answer is pi over 3. And we can check that because right here is pi over 3 for 60 degrees. Okay. And then if we want to go from radians to degrees, we are going to do something like, we'll do pi over 2. So how many degrees is pi over 2 radians? And so now I want 2 pi down here because I want radians and radians to cancel. And I want 360 up here. Okay, so I want the radians to cancel the radians. This pi right here is going to cancel this pi. And because this 2's in the denominator and this 2's in the denominator, this turns into 360 degrees over 4. And this becomes 90 degrees. And we can check that by going over here. So for pi over 2, the degrees equivalent is 90 degrees.